Okay, so more related rates. This is one question, but in three separate parts. Okay, so here we go. A balloon is rising vertically from the ground. Okay, so again, there's a picture that you can look at a rate of 3 feet per second. Okay, so that's dy dt, 3 feet per second. A person standing 75 feet away, so the person's over here, from the point on the ground directly below the balloon. Okay. And if I label the hypotenuse as z, I can see that I have a Pythagorean theorem going on. I've got y squared plus 75 squared should equal z squared. Okay, so that's everything that I know based on that picture and what I've read so far. Okay, so for question A, find the rate in feet per second that the distance between the person and the balloon, so I'm finding dz dt, when the balloon is 40 feet above the ground, so when y is 40. Okay, so if I take the derivative of this to put this whole thing into motion, I get 2y dy dt plus, oh, I don't even need to put the plus because that's a constant, right? If it's a constant, I don't have to take the derivative of it. So that will equal to z dz dt. Okay, and hopefully I have enough to plug in here. Let's see. I'm going to get rid of the 2's on each side. So I've got a y value. I have a dy dt value. I am trying to find this, but I don't have a z. So let me come off into the margin and find my z. 40 squared plus 75 squared equals z squared. Okay, if you grab a handy dandy calculator and compute this, you'll get that z is 85. So 85 times dz dt. And solving this and reducing, I end up figuring out that dz dt is 24 over 17. Okay, next. At what rate is the angle? Okay, so there is an angle that is changing in radians per second. Okay, so I'm finding d theta dt when the balloon is 40 feet above the ground. So again, when y is 40. Okay, so what I need is some sort of an equation. Let me look at this thing really quick. I need an equation that involves theta and y. And the only other number that I have is this 75. So that means I'm going to be using tangent. It's opposite over adjacent. So the tangent of theta is y over 75. Okay. So let me take the derivative. Secant squared theta d theta dt is equal to 1 over 75 dy dt. Okay, let's plug in what we know. Oh, well, crap, I don't have secant. Here's the triangle. I know that's 40. I know that's 75. Oh, wait, I do have that. Oh, never mind. I do have secant. Secant is 85 over 75 squared d theta dt equals 1 over 75. And then dy dt, do I have that somewhere else? I think it's at the top. It's a 3. Okay, and again, you can break out a calculator, figure out that d theta dt equals 9 over 289. That's radians per second, by the way. You know what? I probably should have put the units on this one too, above. I forgot to. It's feet per second. Okay, so then for this last part, The balloon continues to rise above the ground until it eventually pops and begins to fall vertically back down towards the ground. Okay, when the balloon is 100 feet above the ground, the distance between the person and the balloon is decreasing at a rate. Okay, so what do we have? We have dz dt, right? Right here, the distance between the person and the balloon is decreasing, so that's negative. Find the rate that the height of the balloon, so we're finding dy dt, specifically when it's 100 feet above the ground. When h, I don't know why I said h, I should say y is 100. Okay, so I already have the derivative, right? We did the derivative earlier, and we divided everything by 2. So it is y dy dt equal to z dz dt. And if I put in the numbers that I have, the y is 100. The dy dt is what we're finding. The z that we have. Oh, this is a different z. So the height is 100. The person is still 75 away, but our z right here is different. And if you solve the Pythagorean theorem, 75 squared plus 100 squared equals z squared, you'll get that z is 125. That looks gross. Let's try that again. And then, oh, we have dz dt. Erase again. Dz dt is negative 25. Okay, so solving this for dy dt, we should get negative 125 over 4. And the units on that should be feet per second. Okay, again, please come in with your questions if you have them.